All right, so I wanted to make another video and do some more actual scripting, because in the last video I didn't really go too much into detail with the scripting. So in this video I'm gonna implement this idea I had, which is basically a matter-eating worm. So it's a sort of worm that will move around with physics, and then once it hits the floor, it will start digging through it and go up again over the surface and sort of jump over the surface and continue like that. So yeah, let's do that. First thing I'm going to do is I'm just going to create a sphere and use that as his body for now. So I created that and then I immediately copied it to a Voxel object. And now I'm going to open the hierarchy and rename this, call it worm, and add a script which I'm going to call worm as well. So this is going to be the body of the worm for now. And I'm also going to use a few of the examples I put on the documentation website. So there's this physics script I put here, which I'm going to use for the worm's physics. So let's just copy that, make another new script called simple physics. I'm going to open that, replace it with the stuff from the website, and we should have the worm script right here. So now the object falls down because of the physics script. Basically the physics script it's a very simple physics implementation that makes objects have velocity and angular velocity, like rotation, and it makes it collide with the floor. So once it lands, it stops there. And actually we will probably turn it off later because we want it to go through the floor. So yeah, let's start writing the worm script. So first of all, we want the worm to start digging whenever it hits the floor. So what we can do is we do a raycast forwards to detect if the worm is approaching terrain or inside terrain. So I'm going to make a function, call it check collision, and also we should probably find the physics component. So it's gonna be object find script simple physics, and now we're going to make a raycast. So we're gonna use the velocity of the object to determine the forward direction. So I'm simply gonna always raycast in the direction the object is moving right now. So that's the velocity. So we can read the velocity here and like that. Yeah, so we're going to raycast from our position forward, and actually we want to customize this collision a little bit. So we're going to use the filter to, for now, don't use non-static objects, so the raycast will not collide with anything that's not the big scene here. So it doesn't, for example, collide with the object itself, the sphere. Then let's get the first hit, call it hit, and then do if hit then. So if our array hits something, let's print, see if this works for now. We're gonna check collision every frame. So now it's already printing one. I move it up here, it stops printing, so that's good. Yes. So, but for some reason when it's falling, it is still hitting something. So I have a feeling it's still colliding with itself for some reason. Also, we should normalize the velocity. I think that's the problem here. So the velocity can be a very long vector, but we just want to make it a unit vector. So it's like one meter. Now it's 1 meter ahead. So now it hits the floor and prints 1. And when it's up here, it's not 1. I'm not sure why the object is falling so slow now. Interesting. Yeah, so the physics script is not ideal. It's not using fixed update. So maybe it behaves slightly different depending on the frame rate. But this seems very slow. Why? Aha, because I normalize velocity, but that's actually normalizing the velocity of the physics component. So I have to copy this vector so we don't actually modify the vector in the physics component. And now I believe it should be fast again. Yeah. Okay, so this seems to be working. Now, next thing we want to do is start removing voxels whenever he's hitting floor. And for that, we can actually use the other example here. So there's a voxel edit example. and it has this function make line, which basically makes a capsule from one point to another, a voxel capsule. So I'm going to use that function, and can just remove the color here. And this one adds voxels, but we want to remove. So I'm going to replace that with erase. And same thing, we want to ignore non-static objects. So we don't add voxels to our own body and other random objects for now. Later we can maybe change this so it actually edits other stuff as well except our own body. So now we can use this function to call it erase line, maybe erase line, and we can use this function to erase a line from P1 to P2. So put it here, and we're gonna erase from our current position and perhaps simply using the velocity again. So we're simply erasing in the direction we're moving forwards. So the velocity is now normalized to a unit vector of like a length of 1. So let's make it a little bit shorter, perhaps. Actually, yeah, I think this is not the right way, but let's try it first. Nothing is happening. Something happened. Okay, so the hole is tiny. Let's change this thickness of the capsule to the scale of our object without a multiplier. So it's exactly 1 right now. And it will match the size of the sphere. We go up again. Yes, so I believe we are digging down. Actually, it has to be half of it because it's a radius, not a diameter. So let's try this somewhere else. Okay, so what's happening now is the object is digging, but then there's some gaps in between. And this is because we're just using some random length, but the object might have moved more. So let's actually use the same code like here, where we store the last position and then always dig from our current position to the last position. So we're gonna erase the line if the position has changed, erase the line from the last position to the current position, and then we store the last position here. So now we're gonna update this edit every time we hit something. See if that works. No. And of course it doesn't work again because we're not actually erasing forward. So now we have to add the velocity here again. So it's gonna be velocity. Okay, see if that works. And another thing that might be sabotaging the script right now is that the physics component also stops moving once he hits the floor, but yeah, this works. So yeah, it fell all the way through. I'm not sure why the hole looks like that though. It's strange. And so let's make the worm always start at some position very high up, so we don't have to find it. Oh, what happened? Oh, oops. Wow. Interesting bug. Interesting error for that. Yeah. Okay. So I think if we restart now, he starts somewhere up here, but this is still not quite working the way it should. So let's see what's going on here. So first of all, let's modify the physics script because it does a collision check right here. And when it collides with something, it sets the object to be sleeping, so it stops moving. So we're just going to turn off the collision check, and that way it never stops moving. And yeah, I think now it's falling all the way through. And let's see, this looks correct. So, and the other thing is I might have overcomplicated this because we don't really have to do a raycast check to see if we need to erase. We can also simply erase, but yeah, it seems to work. So let's try it one more time in a different position, a little bit slightly to the side. Let's see. Okay, where did it land? See this again. Okay, so for some reason those tunnel is not the normal shape I would expect, and this is because I think something is wrong with the velocity maybe, but actually we don't need to worry about it. Just simply erase a line from the last position to the current position all the time. So I'll put that in the update. So whenever or all the time it will simply erase, and I think now this should correctly. So move it one more time. Yes, so we get a straight line. And now next thing we want to do is whenever it does collide, we want the object, the worm, to start moving up again. So if we have a hit here, then we're gonna add to our to our velocity. So I'm gonna do plus vector 3 up, and then some amount of force. So maybe, not sure, something. Let's try a lot for now. And so now when he hits the floor, he should move up. Let's try a different position again. Where is it? Good. Ah, there it is. Oh, okay, so he shoots up. And yeah, so he basically bounces pretty hard. And also what happens is every bounce is different because he might hit the floor for a variable number of frames, like 1 or multiple. And if it's multiple, then he will add more velocity. So let's try less force first of all. Yeah, so now we get this kind of bouncy behavior where he actually digs inside and then shoots up again, which is kind of what I want. The problem is that it's again not digging a hole. So let's see why that is. Can like draw a line here and draw a line for this operation. So just draw a line for the erase operation. Yeah, so it does actually do an edit. I think it might just, yeah, this looks like it actually happened. I think it just took a long time for the edit to happen, maybe. So I think we could also make this object a bit less heavy, so, or less fast moving. So I mean, so let's reduce the gravity to something lower and see how that behaves. Yeah, so that's a slower movement. And somewhere else again, test this. For some reason, the edit is not happening. So it seems like the line doesn't go far enough. So, yeah, it makes sense. So the object immediately shoots up again, and it never has a chance to really collide with the floor much. So let's try this again. Add a little bit of velocity. So also draw that just to make sure. Okay, let's add more. I be a whole meter ahead now. Yeah, and it is. Or is that a meter? No, is it cam? Yeah, so faster the sphere is moving, the more bouncy the reaction will be too, which I don't know if that's good or bad, because it might accelerate more and more. But I think overall I think the behavior is not too bad. And the problem here is that, or was that, 1 is not a lot because the sphere is pretty big and the position is the center of the sphere. So that's why smaller number was not enough. In fact, we could even try a bit more. See that, spawn it somewhere else again. Okay, I think this is pretty good. So now we're gonna add the sideways movement. So I'm gonna make another function here. It's called update smooth, and we're gonna simply add to our, or perhaps set the velocity. So using Perlin noise, we can generate some sort of random movement. So let's do this master.Perlin noise, and then we're gonna use the time. This is gonna be X and Z. So this is two different random noises. And then I think what we should try is setting this directly for now. I might add it later, but for now let's simply add the Y component, the previous velocity, and add Y, and then the Perlin noise for X and Z multiplied by 10, because it's a number between -1 and 1, so it's -10 to 10. I think it might be a bit much. Let's see. Okay, so we have random movement. I'm gonna remove the line now. And yeah, obviously this is way too fast, and I would say too weak. So we want the movement to be much smoother. So let's slow down the time a bit. Yeah, so if you don't know about Perlin noise, it's a sort of continuous noise. And if we put in time, we get, or if we put in any number that increases slowly, we get sort of a continuous value that goes up and down. It's not just random. So if we slow down time, the value basically changes much slower. So let's make it 10 times slower, and let's make it stronger. See how that looks. So yeah, he, I guess pretty quickly he just disappears. And I think he should go much deeper underground as well. So let's make it a bit weaker so it doesn't disappear. And then actually increase gravity again. I think it's a bit too floaty. See how that looks. So yeah, he does go a bit lower now, a bit deeper. Wow. I don't know where he went. Yeah, this is great. So let's see the tunnel. Okay, so now he's just hopping around. It is a little bit annoying how he digs so much ahead of him because it creates this like strange, it looks like he didn't actually touch what he dug. Wow. Okay. Yeah, that's cool. That's cool. And I think it's pretty funny. We could actually try to, just for fun, we could try to add the make line function again and make him draw a trail. So yeah, color, it's gonna be white for now, black can use the same. So not gonna erase, gonna make a line, see how that looks. So he's gonna have a voxel trail. Yeah, he's adding to himself, that's a problem. And let's fix that real quick. And I think he might have, let's see. So we're using non-static again, so he doesn't add to non-static objects like himself. And now, yeah, this is pretty good. Let's restart this. I think this is actually more interesting than the digging version. It definitely creates very cool looking trails. Yeah, this is very cool. Okay, now he disappeared. Did he fall through the map? Yeah. So if he has too much velocity and this map is in some places quite thin, he will just fall through it. And yeah, that's maybe fine. We can add some code here that's put an update move if the position is too low, if it's smaller than -20, then simply reset them. I think that makes sense. Maybe use the current position and move. Usually do like this. See if that works. And let's fix the sphere because there's random stuff in it. So I'm just gonna make a new one. Okay, it looks like I'm stressing the database here. Turn this off for a second. So he did do a lot of edits, especially when he was falling down, I guess. And the Voxel database is still processing that. I don't know how far he went down. So yeah, it looks like it's still working on those edits. And while it's doing that, I cannot make any new ones. So while this is processing, let's work on the color of the trail. Let's see. I mean, we could randomize it, or we could change it over time. We could also use Perlin noise for it. Let's try that. I don't really know what that looks like. So the color here, actually let's make a function for this random color. It's not quite random, but yeah. And then let's make 3 components here. Use time again. So we're just gonna different numbers each and try that number. Those numbers. I think they might totally randomized numbers for colors usually end up being a wide range of colors, like really bright colors and really dark colors. So it's usually not ideal, but let's see how this looks. I'm not sure if the Voxel database has recovered. I can try to make a sphere. Yeah, so let's save the sphere as well. Save it as sphere. Actually, just use this name it as by default and replace that here. And then let's activate it again, reset its position, I think. So it's over there. Yeah. Okay, so there's the random Perlin noise color. So I think the thing quite changed from my original idea. I was just gonna make a digging worm, but I think I like this better. I was also previously thinking I would give him multiple body segments. So now he has one sphere. So I was thinking he could have like 5, 6 or so that are like a trail, like follow each other. But since now he has a voxel trail, I think that doesn't really make sense. So maybe this is a completed project. So he fell through the floor again and then teleported up. This is kind of a quick fix, of course. I mean, the proper solution, I would say, is to not have such a thin map. This is just a testing environment. But so yeah, we have this quick fix that he never falls through. What can also happen, of course, is that worm just moves off the map and falls down on the sides, and then he will keep teleporting up and down. or keep falling down and teleporting back up. And yeah, I think the colors kind of work. They're very dark. Actually, just realized they're also in a range from -1 to 1, so this doesn't really make sense. But we could do 1 divided by 2, so +1 divided by 2. So then it's a number in a range from 0 to 1, which is a color. And I think then they will be more brighter. So let's see. Yeah, so it definitely doesn't go to pure black all the time, I think. Yeah, okay, I would say this example is completed. I think it's pretty fun. It turned out pretty fun. Wow, we really shot up there. Wow, what happened? Okay. If you want to try this Voxel engine and try to make something yourself, and if you have not yet, you can join our early closed testing group. So these tools that I've just been using, the editor and the scripting environment and the API and so on, are all in an early testing stage. And right now we are doing a closed test. So you can sign up and we may approve you and send you a build that you can try out to try these early tools and try to build something yourself. So if you want to do that, just check out the link that is going to be somewhere with this video. So yeah, that's it.